Welcome to the chemistry session. So today we are discussing about the solubility. So what is the meaning of solubility? So whenever I am going to take a solute and I am going to add in a solvent, how much amount of this solute is dissolved in a solvent, that is nothing but solubility. So we can define that solubility is the maximum amount of substance that can be dissolved in specific amount of solvent. At specific temperature. So, are you getting? Solubility is the amount of the substance, that substance is nothing but solute. Solubility is the amount of the substance that can be dissolved in a specific amount of the solvent at a specific temperature. The maximum amount of the, for example, I am taking here some solvent. Okay, how much it is possible for me in order to add the solute, that is the maximum amount of the solute that can be dissolved in a specific amount of the solvent at a specific temperature is called as solubility. Clear? So, this is the definition of the solubility. Next, what are the factors affecting on the solubility? The factors affecting on the solubility, first one is nature of solute. Depends upon the nature of the solute, the solubility will going to be changed. So, even it depends upon the nature of solvent. And one more factor, that is temperature, and one more factor, that is pressure. Okay. So, these are the factors which are influencing on the solubility. First one is the nature of solute, and second one is the nature of solvent, and the third one is temperature, and the fourth one is the pressure. So, all these are the factors which affect on the solubility. Okay. Let me tell you one more thing. Here, in one beaker I took the water and I am going to dissolve salt or sugar. In another beaker I took benzene, here I am going to dissolve naphthalene or anthracene. So, if I take this salt and sugar, I want to dissolve in the benzene, means they will not going to get dissolved. They will not going to get dissolved. All the solutes will not going to dissolve in all the solvent. Are you getting? All the solutes will not going to dissolve in all the solvents. Then which type of the solute is dissolved in which type of the solvent? So, keep in mind that there are certain solutes, that is the polar solute dissolves in polar solvent. Polar solutes are dissolved in polar solvent, and similarly non-polar solute dissolves in non-polar solvent. Okay, the polar solute dissolves in polar solvent and non-polar solute dissolves in non-polar solvent. It means the like dissolves in like, where the intermolecular interactions it means if the solute and solvent both are having the, if the solute and solvent, if these two are having the same intermolecular interaction, means that solute get dissolves in the solvent. It means the like dissolves in like dissolves in like. Clear? So, all the solutes cannot be dissolved in all the solvent. The polar solute is dissolved in polar solvent and the non-polar solute is dissolved in non-polar solvent. It means which type of the solute and solvent both are intermixed, where the intermolecular interactions of the solute and solvent are same. In that case, the solute get dissolves in the solvent. It means the like dissolves in like. So, this is how we can tell. For example, salt can be dissolved in water, sugar can be dissolved in water, but naphthalene cannot be dissolved in water. Similarly, the naphthalene and anthracene both can be, it means both can be dissolved in benzene, but salt and sugar cannot be dissolved in benzene. So, the reason is when the solute and solvents are having the same intermolecular interaction, then only it gets dissolved here, or else it will not going to get dissolved. So, this is the definition of the solubility and the factors affecting the solubility, and which type of the solute gets dissolved in which type of the solvent is explained. Clear? So, next we are going to discuss about the solubility of a solid in a liquid. Solubility of solid in liquid. So, this is the concept which we need to discuss. Okay. So, let us come. As I am telling you, solid in liquid, it means solute which is solid, because I am dissolving solid in liquid, plus solvent, solvent I took as a liquid which forms the solution, which forms the solution. So, the solid is dissolved in liquid, there is a formation of the solution. Okay. Let me tell you two terms here. One is dissolution and one more is crystallization. Okay. So, these are the two terms which you need to know. Dissolution means whenever I am going to add the solute to solvent. So, what happens? The solute gets dissolved in that solvent and the concentration is increases. That process is called as dissolution. It means the solute is dissolved in solvent and concentration increases. Okay. So, see here, this is the solvent. So, I am adding the solute. This is the solvent. As I am adding the solute gets dissolved here and it increases the concentration. This process is called as dissolution. Next, crystallization. So, carefully observe here. So, here the solute is dissolved here. It means there are some particles of the solute which are dissolved in the solution, and I am adding again the solute to this. It means solid solute I am adding. Here also there is a presence of some particles. Okay. Here also there is a presence of the particles. So, what happens when I am adding this solid solute? The particles of the solid solute collide with the particles of the solution. Collide with the particles of the solution, that is solvent. So what happens when these two are collide, there is a separation of those particles. There is a separation of those particles. That process is called as crystallization. That process is called as crystallization. There is a collide or collision between the particles of the solid solute with the particles of the solute which are dissolved in the solution. So during that time the particles are, those are what we can say take out as in the form of crystals. That process is called as crystallization. Okay. So collision between the particles of solid solute and particles of solute dissolved in solvent. So there is a separation, of particles in the form of crystals. This process is called as crystallization. It means whatever we are adding the solute, that is dissolving and the concentration increasing, that is the dissolution. While crystallization is the separation of the particle due to the collision between the particles of the solid solute and the particles of the solute which are dissolved in the solution. So see here, when the rate of dissolution becomes equals to rate of crystallization, when the rate of dissolution becomes equal to the rate of crystallization, there is a dynamic equilibrium occurs. There is a dynamic equilibrium occurs. It means what? Rate of dissolution. How many particles are dissolved in the solvent, that becomes equal to how many particles are getting separated. So during that time there is a equilibrium. There is a equilibrium occurs, that is what we called as a dynamic equilibrium. So I will write here solute plus solvent, there is a dynamic equilibrium. So see here, when the solute is dissolved in solvent, what happens? It gets soluble and the concentration increases. This process we can say that dissolution. Are you agree? And then what happens? Reverse, and there is a solution. So when I am adding this solute, and here also some particles, they will collide with each other and that will get separated in the form of crystal, means this backward reaction is crystallization. This backward reaction is crystallization. So when the dissolution and crystallization becomes equal with each other, so there is a dynamic equilibrium is occurred. Clear? So let me tell you two more definitions. Saturated solution and unsaturated solution. Okay. So I hope you understood this. Simple. When the rate of dissolution means I am adding the solute and the solute getting dissolved in the solvent and it increases the concentration, that process is called as dissolution. And then when the particles of the solid solute collide with the particles of the solute which are present in the solvent, those gets separated out in the form of crystal, that is what we called as crystallization. So, when the rate of crystallization and rate of dissolution becomes equal, that time there is a dynamic equilibrium is going to occur. So, if I represent through the solute and solvent reaction, the forward reaction is itself dissolution and the backward reaction occurs as a crystallization. Okay. So, let me tell you saturated solution. So, I took one solvent and I am adding the solute. Add a little amount of the solute starting and dissolve and go on adding the solute at certain time. After certain time, the solute does not dissolve in that solvent. Such a solution is called as saturated solution. So, let me write the definition. Saturated solution is the solution in which no more solute can be dissolved. No more solute can be dissolved. Okay. Let us take one example. Take a glass of water and go on adding the sugar. Starting it will going to dissolve until certain level it will going to dissolve. After that there is the sugar will not going to dissolve in the solution, that is in the water. So, that solution is said to be a saturated solution. It means the solution in which no more solute can be dissolved. So, at a particular time the solute cannot be dissolved, that solution is said to be saturated. And then until that whatever the solute dissolved, there is a solution. Until that whatever the solute dissolved, there is also a solution. That solution is called as unsaturated solution. It means unsaturated solution is a solution in which maximum amount of solute is dissolved. Maximum amount of the solute is dissolved. So, as I am adding the solute, it gets dissolved, it will go on dissolving. So, when it stops dissolving process, that time it becomes saturated. Until that it becomes unsaturated. It means unsaturated solution is a solution in which maximum amount of the solute is dissolved. When there is no dissolution, it becomes saturated. What is the meaning of saturated? Saturated solution is solution in which no more solute can be dissolved. Clear? So, this is how we can explain the definition of the saturated and unsaturated solution. I hope all of you are getting what I am telling. So, let me tell you few more concepts. Here we are discussing effect of temperature on solubility of solid not in liquid. Effect of temperature on solubility of a solid in liquid. Okay. So, let us go for this. Solute plus solvent which occurs at a dynamic equilibrium, there is a formation of the solution. Keep one thing in mind, that we are talking about solubility. What is the meaning of solubility? The amount of the solute present in the solvent. Okay. So, in this reaction the solute is dissolved in solvent and it forms a solution. This is nothing but dissolution. So, solute and solvent, there is a dissolution, forward reaction is a dissolution. It means I am adding solute to solvent, so that what happens, it will going to dissolve and it increases the concentration, that is nothing but dissolution. Dissolution means this solute is getting dissolved or this solute is soluble in the solvent. This dissolution term I can even take it as a solubility. Are you getting why I am taking? See, whenever the solute is added to solvent, it gets dissolved and it increases the concentration. That is the dissolution. Okay. And what we are telling, solubility is nothing but the amount of the solute present in the solvent. So, this dissolution is nothing but solubility. So, we are discussing the solubility. Effect of temperature on solubility means we have to concentrate on this first solubility, that is a forward reaction you have to concentrate. Next, how the temperature will going to affect on this solubility? Let me tell you first case. Suppose the dissolution is exothermic. Suppose the dissolution is exothermic. So, exothermic means there is a release of heat. Solute plus solvent solution plus, because it is exothermic, there is a release of the heat. Because it is exothermic, there is a release of the heat. Now, I am going to increase the temperature. Temperature is increased. Temperature is increased. According to Le Chatelier's principle, according to Le Chatelier's principle, the equilibrium does not accept it. Again one more question arises, what is Le Chatelier's principle? Let me tell you, any reaction is in the case in equilibrium means, any reaction which is obeying the equilibrium means, suppose I am changing any temperature, pressure or any other factor, the equilibrium does not accept it. It tries to nullify that effect. It wants to make the effect as 0 either by favoring the forward reaction or by favoring the backward reaction. So, you better understood this concept in your first PUC. So, let me tell you this concept. So, solute plus solvent which is in a dynamic equilibrium with the solution, as it is exothermic, I am telling you, and this dissolution is exothermic, there is a release of heat. Now, I am increasing the temperature. Now, I am increasing the temperature, but the equilibrium does not accept it. Equilibrium does not accept it. So, what happens? It starts to favor the backward reaction. It starts to favor the backward reaction. See here, in the solution there are, let me take here, there is a formation of NaCl. So, what happens? These will going to form the ions. These ions are starts to move towards reactant side. This starts to move towards the reactant side because the equilibrium favors the backward reaction. So, what happens? Already in the reactant side, solute and solvent particles are present. Already in case of reactant side, solute and solvent particles are present. These particles do not have a space here. These particles do not have a space for the solubility. Yes or no? Because these, here the solute and solvent ions are present. How these can able to dissolve here? Because more space is not available. So, what I mean to say is that here the solubility will going to be decrease as temperature increases, solubility decreases. Very important. When the dissolution process is exothermic, when the dissolution process is exothermic, if we increase the temperature, the solubility decreases. See here, when the solute and solvent are there, there is a dynamic equilibrium and solution will going to form. As I am telling, it is exothermic, there is a release of heat. Now, I am going to increase the temperature, the equilibrium does not accept it according to our Le Chatelier's principle. So, what happens? It favors the backward reaction. It favors the backward reaction and the ions of the solution side comes towards the reactant side. But there is no space because already these ions occupied the space. So, we can say that the solubility decreases. Suppose the dissolution is exothermic, means during that time if you increase the temperature, the solubility decreases. Clear? So, let me tell you, if the dissolution is endothermic, suppose the dissolution is endothermic. Okay, suppose the dissolution is endothermic. So, what happens? Solute plus solvent, there is a equilibrium and this process is the dissolution, it means solubility itself and solution. As I am telling you, endothermic, it means heat will be here because it is consuming, this reaction consumes the heat. Okay. So, it is endothermic. Now, I am going to increase the temperature. Now, increase the temperature. Now, increase the temperature. So, if I am increasing the temperature, the equilibrium does not accept it. Okay. It is not, this equilibrium is not ready to accept it. What it does? It favors the forward reaction. It favors the forward reaction. It means, however, this solute and solvent, more forward reaction occurs, there is a formation of the solution. So, even you can add many solute here. There is a space. Why there is a space? Because the equilibrium shifting towards the forward reaction. It favors the forward reaction. More solute and solvent goes through the solution. So, there is a space for few more addition. There is a space for the addition of few more solute. So, what happens? It means I can add more solute here, means the solubility increases. The solubility increases. So, we can say that if the dissolution is endothermic, then during that time, if the temperature is increases, means if temperature increases means the solubility also increases. Why you are getting? See here, the dissolution is endothermic, solute plus solvent plus heat. Endothermic, it means it consumes the heat. Now, I am going to increase the temperature, the equilibrium does not ready to accept it. Okay. So, what happens? It favors the forward reaction. So, more number of these particles move towards the solution, means here there is a space for addition of the solute. So, the solubility increases as the temperature increases. So, very important, when the dissolution is exothermic, during that time if I increase the temperature, solubility decreases. But in case of endothermic, if I increase the temperature, the solubility increases. Clear? So, these are the two cases which we are discussed. Next one is effect of pressure. How does the pressure will going to affect for the solubility of a solid on liquid? See here, the pressure does not have any significant role. It means the pressure will not going to cause any increase or decrease, it does not have any significant. Why the pressure does not affect the solubility of a solid in liquid means the solids and liquids are highly incompressible, only the gases are compressible. So, we can tell that the solid and liquids are highly, it means those are solids and liquids are cannot be compressed. So, as this cannot be compressed, suppose this is a solid, by applying the pressure we can compress, but these are non-compressible, that is why the pressure does not have any significant role on the solubility of a solid in liquid. So, keep in mind that the temperature plays a very important role, depends upon the dissolution is exothermic or endothermic, and pressure does not have any role because of the solids and liquids are highly incompressible. Clear? So, we will continue the next concept in our next session. Thank you.